In this lesson, I'm going to talk first about how to actually apply the equilibrium constant in order to further study chemical reactions. And specifically, we can use the equilibrium constant in order to predict the direction that the reaction is going to go if it's not already at equilibrium. So what direction does the reaction need to go in order to reach equilibrium? So in order to determine this, we use a value that's called your reaction quotient, which we represent with a Q rather than a K. And your reaction quotient, if you substitute the concentrations of the reactants and the products into the equilibrium expression, but you're not at equilibrium, that you end up calculating Q, your reaction quotient. So Q is calculated the same way that K is. The only difference is that the concentrations that are plugged into the chemical equilibrium expression aren't actually the concentrations that are found at equilibrium, and therefore we call the constant that is acquired by plugging in those values the reaction quotient rather than the equilibrium constant. So by comparing your Q and your KEQ, which is your equilibrium constant, whether it's your Kc or your Kp, you can actually predict what direction the reaction is going to proceed. So for example, if your Q equals your K, what that tells you is that your reaction is actually already at equilibrium. If instead, however, your Q is larger than K, let's actually think about what this means. If your Q is larger than your K, that means that you have more products than what is found at equilibrium. Because remember, your products are found in your numerator. The concentrations or the pressures are found in your numerator. So your Q, therefore, demonstrates that in order to reach equilibrium, the reaction must proceed to the left, getting rid of product, making more reactant in order to equal your K. So it's going to proceed to the left to make more reactant. In contrast, if your Q is less than K, what that means is that you have more reactant than is found in the equilibrium state. Therefore, the reaction has to proceed to the right in order to produce more product, therefore making your Q large enough so that it can equal your K.